Hey, what's up? This video is about simplifying complex fractions. So first of all, what is a complex fraction? Well, it's something that looks like this. It's like if you had 5/3 divided by 7/12. The reason it's called a complex fraction is because it's how it's like sort of like a fraction within a fraction. You have a fraction divided by another fraction. So it can be a little confusing, right? But the best way to go about this is to simply rewrite this in a different form that looks a lot more familiar. So the essential thing to recognize is that the only thing that's going on here is you're really just going 5/3 divided by 7/12. So you could rewrite this problem as 5/3 divided by 7/12. Now, notice, this is a little more familiar looking, right? Because when you get to this point, maybe you might have learned that the way to divide fractions is to simply invert and multiply. And by the way, if you're not clear on this, I would say watch my video on multiplying and dividing fractions. It'll make this clear. But assuming you know how to do this, then it's just simply a matter of inverting and multiplying. So I'm going to rewrite this again. So instead of it being 5/3 divided by 7/12, it's going to be 5/3 times 12/7, because remember, when I divide fractions, I just simply flip the second fraction and turn it into a multiplication sign instead of a division sign. So when I do this, I get 5 times 12 is 60, because I'm multiplying straight across, and then 3 times 7 is 21. Now this is the answer. If I were to reduce this using equivalent fractions, then I would just get 20/7, because I divided 3 into the top and I divided 3 into the bottom. 60/3 is 20, and 21/3 is 7. So this is your fully reduced answer. So what this means is that 5/3 divided by 7/12 is 20/7. Now, as a final note, I want to point something out, okay? If this particular way works for you, that's great. Now, there's a shortcut way though. There's a shortcut here that could save you a little bit of time if you feel comfortable doing it. You don't have to, but it's one of those things that I'm just going to point out just in case you want to. All right. So notice something. It turns out that you can actually look at these numbers, and you see how 5 and 7 are separated by one space, and 3 and 12 are separated by one space. It turns out that when you're dealing with complex fractions, you can actually cancel factors from numbers that are separated from one space. So for example, you see how 3 and 12 have a common factor of 3? What that means is I can cross this off and cross this off. This becomes a 1 and this becomes a 4, because 3/12 is the same as 1/4. So if I rewrite this, it's simply 5/1 divided by 7/4, which is 5/1 divided by 7/4, which, remember, when I rewrite it as a multiplication problem by inverting and multiplying, I get 5/1 times 4/7, multiply straight across, and I get 20/7. 5 times 4 is 20, 1 times 7 is 7. So, boom. 20/7 is 20/7. 20/7, 20/7. Cool. So that was just a little proof that this method of canceling factors from numbers that are separated by one spot, that's important, okay? You can't cancel things from a 3 and a 7, or between the 5 and the 12, because they're separated from, they're not separated in this pattern. So only 5 and 7, or only 3 and 12. And just think about this if you think about this for a second, you'll kind of understand why that is, if you imagine bringing this up and flipping it like we did.